So this video is on identifying compounds. It's just a basic chemistry review. So we're just going to go over like what are the different kinds of compounds and like how can I figure out which one is which. And then I'll make a video for each of the different compounds to go more in depth if you're unsure. So there is a couple things that we want to get through in this little lesson, mini lesson. Is we want to identify the type 1 and type 2 type of ionic compounds and actually figure out what an ionic compound is also. We also want to figure out what an acidic compound looks like and what a covalent compound looks like. So what we're really looking at here is what's called nomenclature. Nomenclature is a really fancy word for naming chemical compounds. In this course, we use what's called IUPAC nomenclature, and the IUPAC is kind of a group of chemists, and it's actually called the International Union of Pure and Applied Chemistry. The reason that we use this nomenclature is that so no matter where we are, no matter what language we speak, no matter what country we're in, we all come up with the same formula for something. So like H2O, we all, no matter where we are, we all want to be able to recognize that H2O means water. Each of the compounds or each type of compounds has a kind of a slightly different way of naming them. They're not extremely different, but they are a little bit different. So you do need to look at each one and figure out which kind of compound they are so that you can identify them. So really there's pretty much just 4 different kinds of compounds, and as long as you know the 4 different types and what to do for each type, then you should be easily able to name them all or put the formula together. So this is what a periodic table of elements looks like. The one that I give you in class is not quite as pretty just because I don't have a color printing budget. This one is a good reference because it actually shows you the phases of things, so whether or not they are a gas or a liquid or a solid. And so you can see that, for instance, like nitrogen is red, so that means that it's a gas. You can see that Ag is black, so it's a solid. There is an important other thing that's not drawn in on here, but you might want to even draw it in with a pencil or a pen on your periodic table that I give you. But you kind of want to draw in a staircase right about here. So this staircase, what that does is it actually separates these ones over here, and we call these ones non-metals, from these ones over here. So any of the ones over on the right side, left side, are metals. Any of the ones on the right side are non-metals. So the ones on the right side, another name for non-metals is that we call them anions. And another name for metals is that we call them cations. Okay, and it's important for us to, when we're trying to look at those compounds, for instance, we're going to need to know whether or not we have a metal. So let's say like something from over here mixing with something from over here, right? So we're going to look at where the parts of the compound are by carefully looking at the table. What else can I tell you about this periodic table? You'll see that down here, this number is 57, right, and goes to 71. That's actually supposed to fit into this part that goes here. I don't know if you've ever noticed this, but the table would look kind of funny, right? So they put it down at the bottom down there. Hydrogen, sometimes I want to point out that hydrogen, sometimes you'll find it over here, but often on many tables you'll actually find it over here too. It can act as a metal or a non-metal. Okay, now we'll just go on to the different types of compounds. Oh, I think I'm going to show you a table of ions first. So this is a table of ions. I give you this one because this one is really very similar in shape to your periodic table, right? So I find it's easier for students often to find it. This one actually has the staircase in it, but you might want to just draw it in again just so we're absolutely sure where it is. What you'll also see is that when we look here on this table of ions, you'll see for sure that these are non-metals, right? And again, I said that they are called anions. Anions actually mean that they're negatively charged. So you'll see that all of these have a negative charge. So they all have a negative charge. And again, these ones all over here, not including this list, but all of these ones underneath here, these are all metals. Remember again that they're called cations, or that they have a positive charge. So you'll notice that they have 3, they have 7, this one has 3. I don't know if you've noticed this before, but the group number at the top, not that I'm ever going to ask you to memorize this, but just so that you see, this group number at the top, the 3, notice that this is 3 positive, this is 3 positive, this is 3 positive, same thing here. These are 2, this is 2, this is 2, 2, 2. There's a couple that we're want to pay close attention to. You'll notice that some of the boxes actually kind of are split in 2, right? So like these ones. What that means is that they could have possibly 2 charges. So they could either be iron 3 or iron 2. And so we're going to talk about this more when we talk about the different types of compounds, but it's really important to pay attention to those 2 boxes that are split in 2. I'm also going to tell you now, because I'll tell you a couple times just to make sure we remember it. The one on the top, if you have to guess which one to use, always guess the one on the top. The one on the top is actually the most commonly occurring in nature, and so that's the one we're going to find the most, if you can't figure it out, that is. For the most part, you could probably figure it out, but if you can't figure it out for some reason, then we're going to use the one on the top. Remember again that this is a table of ions, so that means that these things all have a charge. This is different than the last table because the last table was a table of elements. The elements have no charge on them, so when they're simply an element all by themselves, we don't write these little, these are called superscript numbers on top of them. Okay, these up here are special. They're special in that there are still ions because they all have a charge, and you'll see that they all have a charge. But they're different in that there is more than one thing there. So it's not just carbon, it's not just oxygen, it's not just like silver, let's say. They're poly, because poly actually means many. So there are actually many atoms stuck together to make an ion. So they still have a charge, even though they have more than one thing on them. That means that they can mix with other things. You'll see that the names on these are often different endings, so they end in like ATE or ITE, or maybe an OUS one, but they have different endings. So if you're looking for something that ends in ATE or ITE, that's a good place to start. The other thing is that this table of ions is excellent if you're trying to name things, because I want you just to look at fluoride for a second here. You'll see that on the table of ions it's actually called fluoride. If I went back and looked at my table of elements, you'll see that it's actually called fluorine. So there is actually a difference in the naming. So once it becomes an ion, it ends in IDE, so that's a little bit different. Okay, so first kind of compound is an ionic compound. And ionic compounds can be split into 2 types. So first we'll talk about what an ionic compound is. So an ionic compound is always a metal, so that's something from the left side of the staircase, and always a non-metal, and that's always something from the right side of the staircase. Okay, another way of saying that is just to say that it's a cation and an anion. So it's always a positive and a negative together. These always go in this order too. So it's always the cation and then the anion. So it's always the metal and then the non-metal, always in this order. You don't put the non-metal ever first. It's always the metal first. The type 1 ionic compound, we're going to look at those compounds have a metal or a cation with only a single charge. So for example, magnesium 2 positive. So if you went and looked at your table of ions, you'll see in the second row there, magnesium is 2 positive. They only has 1 possible charge, right? There's only one thing in that box. So any ionic compounds that mix with magnesium, like let's say magnesium chloride, and we'll talk about like where all these other numbers come from after in another video, but magnesium chloride, as soon as I see that it has magnesium in it, right, I'm going to go to my table of elements or ions. It actually, ions would probably be better. So we'll go to the table of ions. We're going to look for magnesium. I'm going to see that magnesium only has 1 possible charge, and that tells me that we have a metal and a non-metal, and it only has 1 possible charge, so it can only be a 2 positive molecule. That means that it's a type 1. Okay, another example is like sodium chloride. So if I look at sodium, sodium can only be 1 positive. It's a metal. Chlorine is a non-metal, so that means that it's a type 1 ionic. Another example would be like aluminum chloride. If I look for aluminum, aluminum only has 1 possible charge. The box isn't split into, and chlorine. And again, we'll talk about these little numbers afterwards. Okay, type 2 ionic compounds have also still, because they're ionic, they still have a metal and a non-metal. So they still have the cation and the anion, and they're always still in that order. The only difference is that when we look at type 2 compounds, they're always going to be the ones where they had the 2 possible boxes. So they're going to have a 3 positive, and they're going to have a 2 positive box, for instance, like iron. Any of the ones where it's split into 2 possible boxes, sometimes in different periodic tables you'll see it like this instead. You'll have it like that. Again, this one in the front is always the most commonly occurring one, but anytime that you see 2 possible numbers for it, that means that it's going to be a type 2 compound, which is kind of easy to remember, right? If it has 2 possible charges, then it's a type 2. If it only has 1 possible positive charge, then it's a type 1. Other examples for it would be like tin. Tin can be tin 4 positive, or it can be tin 2 positive. So we can get a couple different things. We can get iron oxide. This would be iron 2 is how we write it. And again, we'll talk about all these little things about how to write out the names, but iron 2 oxide. We can also have iron 3 oxide. But those are the type 1 and type 2 compounds. We're going to practice this some more too. The next one that we're going to look at is covalent compounds. So ionic compounds actually, so ionic ones that we were just looking at, ionic ones, when we talk about their electrons, they don't actually share them. So one of the people in the kind of marriage of 2 atoms actually gives up. So one gives up electrons, and the other one gains electrons. Covalent's different in that they actually share, so it's kind of a nice relationship in that they share electrons. So they nicely share the electrons, and it's not taking turns just orbiting around one of the atoms. The other thing about covalent is that it's always going to be 2 non-metals together. So unlike ionic, where we had to look for something from one side of the staircase and one other side of the staircase, in covalent, they're always going to be over here on this right side of the staircase. So it's going to be 2 non-metals. So for instance, carbon dioxide is an example of a covalent compound. So if I look for carbon, carbon's over here and oxygen's over here. So they're both over here on this side. So that means that it's a covalent compound. And I always like to use carbon dioxide because that's one you know like off by heart without even really thinking about it. Because you'll notice in the naming, they use these weird little things, right? Dioxide. So why do you think they use that word dioxide? I'm going to guess that you already know, but the di actually tells me that there's 2 of the oxygens in it. And so all covalent ones use a system of naming to tell how many molecules are in it. So we don't look at the charge ever, we just look at the name. So for instance, I gave you this one, dihydrogen monosulfide. The dihydrogen would tell me that I have 2 hydrogens, so it would be H2, like so, and this would be subscript, it's supposed to be below. And then monosulfide tells me that I have 1. So anytime you see like those prefixes like mono, penta, nona, deca, hexa, di, tri, hepta, tetra, and octa, then you know it's a covalent compound. So if you get the name first instead of looking at the compound, then you're going to know that it's a covalent too. So anytime you see any of these prefixes down here, I would strongly recommend that you memorize these if you don't have them memorized already. So this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, this is 9, and this is 10. I think for some reason 4 is the hardest one to remember. Like mono, di, tri, those make sense. But penta, hexa, hepta, those are kind of like math terms, right? Like pentagon is 5, hexagon is 6. So those ones are pretty self-explanatory. So if I said, what's this? You guys probably know that this is carbon, what do you call it? Monoxide. And we'll go over the rules because we don't put 2 O's here, that would look really weird. But it's monoxide, which means that it has 1 oxygen. There's also another little rule, and again, I'll have a whole video just on covalent compounds, but you don't put the mono in front of the first term, only terms after that. So we don't put monocarbon monoxide. Okay. And again, don't worry so much about the endings yet or anything like that. We're just trying to be able to figure out, is it ionic, is it covalent, or is it an acid, so that we can figure out which way to go about naming it. The acids all have to have a hydrogen. So you'll see that in both chemistry 85 and chemistry 95 that we study acids and bases. And anytime we have an acid, there's only a couple exceptions, but most of the time the acid will have hydrogen right at the front. So for instance, H2SO4 is actually called sulfuric acid. So as soon as I see that, and usually it has this little phase behind it, this AQ stands for aqueous. That just means that it's like surrounded by water molecules. It dissolves in water. There's also this one, which is hydrochloric acid. You'll see this a lot in the lab. Again, it will have an AQ behind it. And then this one, you'll see that it has a hydrogen also. In order for something to be an acid, it has to be able to donate a hydrogen, and we'll talk about this again more when we do acids and bases, but it does have to have a hydrogen in order for it to be an acid, because it has to be able to donate a hydrogen, or what we call a proton. These are really the 3 rules for naming acids. I'm just going to put them here. We're not going to talk about them too much yet, but I am going to put them here so that you've seen them once. There's one place that you've seen them. I will go over this again in a whole video on just how to name acids. Okay, so here is my practice sheet for you guys. So, can't do this one because that's too easy, we just did that. Let's pick like this one. So antimony 3-bromide. So would it be a type 1 compound, ionic compound, a type 2 ionic compound, a covalent, or an acidic? If I look up what antimony is, antimony I think is like SB, and bromide is Br, so it's not acidic, right? It doesn't have any hydrogen in it. Antimony is definitely like on, antimony is like over here, so it's definitely a metal, and bromide is over here. So that tells me first off that it is ionic. So now my job is just to figure out, is it type 1 or is it type 2? Well, couple clues here. First, I could look at the antimony box itself. When you look at the antimony box itself, you'll see that it's actually split into two. Okay, that tells me that it's a type 2 there. The other thing is that anytime when we write out the names of type 2, you'll see that they have to have the Roman numeral in the name to tell you which one it is, right? So it has to tell you that it's type 3, and the Roman numeral always matches the charge, by the way. So anytime you see the Roman numeral, that would be a type 2. So I'm going to write antimony 3 bromide right here. Okay, so we did that one. So it's a type 2. Okay, next one is iron 3 oxide. So I picked that one because I just went through the rules and I see the 3, and there's also a 3 here. And if I look at iron's box, I'll see that iron is 3 positive, or it can be 2 positive. So that means that iron 3 oxide is also a type 2. Okay, next. Oh, I see it has an AQ on it, and it has a hydrogen at the front. That means that it's an acid. And this one, barium hydroxide. Okay, well, there's no hydrogen in front, so it can't be an acid. I think that barium is a metal, but if I look on my chart, I'm going to find barium over here, right? So that means that it has to be ionic. When I look at barium's box on my table of ions, I see that barium only has one possible charge. So that means that it's type 1 ionic. Okay, next we'll do carbon monoxide, which is CO. Again, if I look for carbon, here's carbon. If I look for oxygen, here's oxygen. Both non-metals, right, on the right side of the staircase, so therefore it is covalent. Okay, next is Na2O. So if I look for sodium, sodium's like up here, and oxygen again is over here, so that's a metal and a non-metal. So a metal and a non-metal. And sodium can only have one possible charge, so therefore sodium oxide is a type 1. Okay, next is aluminum chloride. So if I look for aluminum, aluminum's right here. Oh, it's actually closer to here, but aluminum, again, but one from each side of the staircase, right? So therefore it is ionic, and aluminum can only have one charge. The box isn't split in two, so that means that it is a type 1. Okay, the next one is chromium oxide. So if I look for chromium and oxygen, chromium's box is actually split into two. So that means I have one from each side of the table, but chromium can have two possible charges. So therefore, chromium oxide is a type 2 compound. Next is HBr. So it has the aqueous behind it, and it has a hydrogen in front. That means that it's an acid. Next is CCl4. That's supposed to say, that's hard to read sometimes, but it's carbon and then 4 chlorines. So if I look for carbon, here's carbon. The chlorine is kind of over here. These are both non-metals, right? So there's two non-metals together. That means that it's not type 1 and it's not type 2 ionic, but it actually would be, oops, and now I did carbon monoxide again. It would be a type, or sorry, not type, but it would be a covalent compound. Okay, so now what we're going to do is we're going to go into each different kind of compound and how to name them and how to write out the names and how to get the formulas for each. So this is just a brief overview of figuring out the 4 types of compounds.